Hi everyone, I am Madam Rosmaya. In this video, we are going to discuss on energy in simple harmonic motion. Okay, total energy in simple harmonic motion, E equals to kinetic energy plus potential energy. So K represent kinetic energy and U represent potential energy. So let's say the object move starting point, a fixed point at the O here, and then it move to the right to X, this displacement X, and then X naught, and going back to a fixed point 0, and to the negative displacement negative X naught, and going back to the fixed point, and so on. It moved to and fro. So the kinetic energy is half mv squared, and we substitute the v that we have derived in the previous video, which is equals to omega squared bracket x naught squared minus x squared. So at point x equals to 0, at the fixed point here, x equals to 0, kinetic energy equals to half m omega squared x naught squared minus 0. So we substitute x equals to 0 into the equation here, so we get this. So therefore kinetic energy equals to half m omega squared x naught squared. So this will be the maximum kinetic energy. Okay, at point x equals to 0, okay, here again, the potential energy is equals to 0. So the total energy will be half m omega squared x naught squared, and then plus 0. So at initial, kinetic energy is maximum and potential energy is at its minimum. So the total energy become half m omega squared x naught squared. So from the principle of conservation of energy, so the total energy is always constant. So this is the total energy and it is a constant value. At the maximum point x naught, this is the maximum displacement x naught. So the kinetic energy will become 0, because when we substitute x equals to x naught into the equation here for kinetic energy, so we get this term becomes 0. So therefore kinetic energy is 0 at the maximum displacement. Okay, now at any displacement, total energy is conserved. So therefore, at displacement x, total energy also equals to half m omega squared x naught squared. So the kinetic energy half m omega squared bracket x naught squared minus x squared, and plus the potential energy. So from this expression, we can determine the potential energy. Okay, we expand the bracket here, half m omega squared times x naught squared, then minus half m omega squared times x squared, then plus u, potential energy. So these two terms can be cancelled out because they are same values, and therefore we get the expression for u. So u is equals to half m omega squared x squared. Okay, then we can plot the E against X graph. Okay, E total just now is half m omega squared x naught squared. So for kinetic energy maximum equals to half m omega squared x naught squared. And for the kinetic energy minimum equals to 0. So for the potential energy will be opposite lah. So the U max will be same as K max. or equals to E total, and for the U minimum also equals to 0. So the graph kinetic energy generally we get just now is half m omega squared x naught squared minus x squared, okay, in bracket here. So it's a quadratic form. The expression is a quadratic, so therefore the shape of the graph is a parabolic curve, okay, and because negative, so it's a curve like a hill shape here, okay. The coefficient of x squared is negative. And then for the U, we derived just now, potential energy is equals to half m omega squared x squared. So this is also quadratic form. The expression is a quadratic form. So the shape is parabolic also, but this time is a smiling curve, because the coefficient of x squared is positive. So the shape is opposite from the K shape. So one is negative, the other one is positive. So this is the graph E against X. For total energy is a straight line, red line here. For the kinetic energy is the green parabolic curve, and for the potential energy is a purple parabolic curve. So these are all the expression for potential energy, half m omega squared x squared, and kinetic energy equals to half m omega squared bracket x naught squared minus x squared, and the E total equals to half m omega squared x naught squared. And make sure when you sketch the graph, sketch nicely so that it must not exceed the E total here. Because energy from principle of conservation of energy, the total of energy is always constant, and the 2 point here when added up is always equals to the E total, and any point you choose here, the total of the energy always must not exceed the E total half m omega squared x naught squared. For graph f against x, we use the relationship between f force with the potential energy U. Okay, potential energy U is half m omega squared x squared, and f is equals to negative du by dx. So we substitute this into U here. So we use derivation rule for f. So we get 2 times half is 1, then m omega squared x to the power of 1, because the power here 2 minus 1 becomes 1. So we get f equals to negative m omega squared x. So this m omega squared is a constant. So from the this equation, this means that f is directly proportional to x. So the graph is a straight line and it's a negative gradient. And the maximum f is substitute x naught into the equation here, we get m omega squared x naught. So for minimum value of f will be negative m omega squared x naught. This is maximum displacement and minimum displacement. Okay, and then for the energy against time graph, just now is energy against x graph. So for the energy against time graph, we use the general solution for x equals to x naught sine omega t plus phi. So this is the phase which is equals to omega t plus phi. So for the object in simple harmonic motion, let's start from the center here, and it move to and fro, okay, to the left and right and back to the left. So we initial means at time 0, x equals to 0. So we substitute x0 and t0 into the general solution here. So we get 0 x naught sine omega times time 0 plus phi. So sine x naught bring to the left becomes 0. Then sine psi equals to 0. So therefore this psi or phi is equals to 0. So when we substitute phi into here, so the general solution become the equation becomes x equals to x naught sine omega t. So the graph x against time will be a sinusoidal graph. So to get v, we derive dx by dt. Okay, dx by dt. So we get omega x naught cos omega t, and we can substitute into the kinetic energy half mv squared. So this v we substitute into here, so we get half m omega squared x naught squared cos squared omega t. Okay, so this v substitute into here, so we get kinetic energy in terms of time. So for potential energy, this x can be substituted into here, so that we get the u in terms of t. So the u in terms of t is half m omega squared x naught squared sine squared omega t. So I repeat, we substitute this x into here, so we get potential energy in terms of t. So now we can plot the energy against t graph. Okay, energy against t graph. So for kinetic energy, before that, the E total from the earlier discussion is half m omega squared x naught squared. So this must be constant, because from the principle of conservation of energy, the E totals must also always constant. Okay, for kinetic energy graph, K against T, this is a cos squared. So that means it's a cosine graph. And because of the squared, so it's always on the positive side. And for the time period here T, so it's become double here, the cosine graph. And then for the U is a sine. So for potential energy is a sine graph, represented by the purple graph. Purple graph is a sine graph. So because of the squared, so it's become positive. Okay, it's not the not on the negative side, because when you square any values that square will always be positive. So this is a kinetic against time, kinetic energy against time, and potential energy against time graph. Okay, we try this example. A particle of mass 2 kg performs simple harmonic motion, and its potential energy U changes with displacement x from a fixed point as shown in the graph. So find the amplitude, find the period, and then find the velocity of the particle when x equals to 0.2 meter, and also find the force on the particle when x equals to 0.2 meter. So the graph is given here. So to find the amplitude, you read from the x-axis graph, to it's represent x value. So the maximum here is given by 0.4. So for the amplitude x naught, or we can use a to represent amplitude, maximum displacement will be 0.4 meter. Okay, and then next question is for the period. To find period, we can use omega equals to 2 pi f and f equals to 1 per t. So we rearrange the equations, become t equals to 2 pi omega. So but we don't know the omega or angular frequency. So to find the angular frequency, we can read from the graph here. Okay, at the maximum displacement 0.4, the u value is 16. Okay, and the potential energy U is equals to half m omega squared x squared. So the x here we use maximum amplitude. If we equate it to 16, so 0.4 for the amplitude. So we substitute into here, and we can get angular frequency. And the mass is given in the questions just now is 2 kilogram. So the answer for omega is, or angular frequency is 10 radian per second. So now we can substitute into this equation of period, 2 pi per 10. So we get the answer 0.628 second. Okay, we've done for the period. Next question is to calculate the velocity of the particle when x equals to 0.2 meter. So one of the method we use is using kinetic energy equation. So from the potential energy graph here, when x equals to 0.2, the value of potential energy is 4. Okay, when x equals to 0.2, the potential energy is 4. So kinetic energy, the total energy is kinetic energy plus potential energy. So therefore, to get the kinetic energy, so total energy minus the potential energy, we can get the kinetic energy, which is 12 joule. And from this 12 joule, we can equate to the half mv squared. For the formula for kinetic energy, half mv squared, then we can determine the velocity of the particle. So therefore, the velocity of the particle is plus minus 3.46 meter per second. Okay, next we calculate the force on the particle when x equals to 0.2 meter. So from the equation that we have derived in the previous slide, force is equals to negative m omega squared x. So we use the relationship between F and U, and we get this expression for force. So substitute the value of mass of the particle 2 kilogram, angular frequency 10 squared, and then the x displacement 0.2. So therefore the force on the particle is 40 Newton. Okay, so that's all for the video. Thank you for watching.